The volume of a pyramid has a formula that is a third times the area of the base, B for area of base, times by the height. So for a square base pyramid, this isn't too bad because W and L would be the same. So it's a third times whatever the width of the base is. So for example, L squared, because it's a square base, times by the height. In the case of a rectangular base pyramid, you would do a third times by W times by L, because obviously this gives you the area of the rectangle on the bottom, times by the height. Simplified slightly, a third WLH. Of course, you could also have like a triangular base pyramid. You'd work out the area of the triangle on the bottom, then times by a third times by the height. It's really important that the height you use is the vertical height. That means it's the height from sort of the middle of the base all the way up to the peak, in this case H. Sometimes you'll be given the slant height, which is the height from here up to the peak, like this. And that will actually be slightly longer because obviously it's going the same height vertically but also going across. So you would need to use Pythagoras to find the height by constructing a right angle triangle whose hypotenuse is the slant height. For example, with this rectangular pyramid, the front face may have a slant height of S. So if we're looking at this slant height here, would have a slant height of S. Then the base of the constructed right angle triangle would be L over 2. The distance here goes from this sort of point effectively to halfway in the middle, so L over 2. H ends up being the square root of S squared minus L over 2 squared. This is derived from Pythagoras and just rearranged a little bit to get H. We may think of a cone as a pyramid with a circle for a base. In this sense, we can repurpose our equation for the volume of a pyramid, only adapt it for a cone instead. Instead of a generic base B, we can use the formula for the area of a circle with a radius of r. So a generic pyramid would be a third times the area of the base times by the height. But in this case, the base is a circle, which we know has an area of pi r squared. So the volume of a cone is a third times by b, but b is pi r squared, times by the height.